Hello everyone. Today we will be discussing the fifth problem of AtCoder beginner contest 357, which is reachability in functional graph. So what is the problem? There is a directed graph with n vertices and n edges. Okay, the out degree of every vertex is 1. So and the edge from vertex I points to vertex AI. So we have to count the number of pairs u comma v such that vertex v is reachable from vertex u. So let's take the first example. This example. Let's copy it here. Uh, let's copy it here. So this example means that the vertex, there is a outgoing edge from vertex 1 to vertex 2. So let's write this 1 to 2 there is a edge. Now 2 is connected, there is a outgoing edge from 2 to 1. 2 to 1 there is another edge. There is a outgoing edge from 3 to 1. There is a outgoing edge from 3 to 1. Now the 4 is connected to itself, so there is an outgoing edge from 4 to 4. Now we have to find the number of pairs u comma v such that b is reachable from u. So uh, so from 1 where we can go to? From 1 we can definitely go to 1. So 1 comma 1 is a pair. Now 1 there is an outgoing edge from 1 to 2. So 1 comma 2 is also another pair. So we can go to 2 from 1. Now from 2 where we can go to? From 2 we can definitely go to 2, and also from 2 we can go to 1. Okay, so 2 2 and 2 1 are other two pairs. From 3 where we can go to? From 3 we can go to 3, we can go to 1, and from 1 we can go to 2 itself. So from 3 we can either move to 3, we can move to 1, and we can move to 2, right? And from 4 where we can move to? From 4 we can only move to 4. So the answer for this is there are 8 pairs such that p is reachable from u. So answer will be 8. Let's check. Yes, the answer is 8. Now let's think about some solution, some brute force solution. So the brute force solution I can think of is that we will we'll DFS from each node. We'll do DFS from each node, and we'll try to find the number of nodes we can move to from this node. Okay, so that is definitely a solution, and the solution will work also, but the time complexity of the solution is, in the worst case, order of n square. Now which is the case where this solution will be at order of n square? Let's say there is a cycle of cycle of length n. There is a cycle of length n. So for every node we will visit n nodes only. So order, the time complexity will be order of n square. Now let's look at the constants. Constants on n is 2 into 10 to the power 5. So this solution order of n square will not help us. So we have to think something better. So for that, let's take one graph, uh, slightly complicated graph. So let's say 1 to 2, 2 to 3, 3 to 4, and 4 to 1. Let's say 5 is connected to 1, and let's say 2 nodes 6 and 7 are connected to uh, 2. Now the solution I will be proposing will only work if a node is part of at most one cycle. Now if there is a graph like this, let's say 1 to 2, 2 to 3, and 3 to 1, then again let's say 1 to 4, 4 to 2, and let's say again another edge from 2 to 1. This 1 and 2 are part of two cycles, so our solution will not work in this case when a node is part of multiple cycles. So what is our solution? Our solution will be, we'll try starting DFS at any node. Let's say we are starting DFS at the first node. Now we'll go to the second node. Now after that we'll go to the third node. After that we'll go to the fourth node. Now from 4 we'll try to go to the first node, but this is already visited in the current traversal. We have that is also important, that this node is visited in the current traversal. Okay, if this node is visited in the current traversal, then we'll mark this, then we'll store something like count of I or dp of I, you can say. The dp of I means that the number of nodes we can reach from the current node. So let's say dp of 4 will be 1, because we can reach from 4 we can only reach to one place. Now after that we will backtrack. Now we'll go to 3. Now from 3, so 3 will be something like, let's say I is connected to AI, right? I is connected to AI. So the total number of nodes is, we can go from I is nothing but dp of AI plus 1, because all the nodes from AI we can go, plus we can go to node I itself. So dp of I is nothing but dp of AI plus 1. dp of I is nothing but dp of AI plus 1. So this value will be 2. Similarly, we will backtrack to 2. The value will be here 3. Similarly, we will backtrack to 1. This value here will be 4. Now here comes one interesting case. is that uh, here we are finding one cycle. No, now uh, we uh, we will try to find what is the starting node of the cycle. So here from 4, you know na, from 4 we tried to go to 1, but as 1 is already visited, so we could not go to 1. That's why when we try to go to AI, but AI is already visited, we know that this node is the start of the cycle. This node is the start of the cycle. So when we are backtracking to 2, we'll return 1. Okay, we'll return this value 1. And again from 2 to 3 to 2, we'll return 1. From 2 to 1, we'll again return 1. Now when we find that this node is the starting node, here you can see that this node is the start of the cycle. Then this value is the current value. This value is the current value of the cycle. Then we will mark each and every node of this cycle to 4. So we mark this as 4, mark this as 4, and mark this as 4. Okay, I hope you get it. That is our algorithm. Now this the node 5 will be marked as 5, 4 plus 1, and node 6 and 7 will also be marked as 5 because they are part of the cycle. I hope you get it. Now let's jump into the code. You'll understand it better. So this part of the code is the important thing, and traversal will point out mark the nodes that are visited in the current iteration. For directed graphs, we for finding cycles in directed graph, we need two types of visited array. One is this visited array, or the nodes which are visited in the current run or current path. Okay, so we'll be marking dpi and traversal I as 1. Okay, now after our iteration is done, after the current node is done, we'll mark trav I as 0. Okay, that means that this node is unvisited from the path. Okay, now here comes the interesting part. The start node will be marked as -1. -1 means that this node is not part of any cycle. Okay, now if this node is not connected to itself, okay, if this node is not connected to itself, and the traverse of AI is, now the first condition is that traversal of AI is not 0. That means that this case, when we are trying to go from 4 to 1, and we find that 1 is already visited in the current traversal, so we'll mark the dp of I as 1, and start is the AI, so we'll mark start as 1. Okay, now here is the second case. If the node is not visited, if the node is not visited, then we'll mark start as dfs of AI, and we'll mark dpi as dp of AI plus 1. Now for the nodes 2 and 3, start value will be 1. So we'll not go into this condition. Okay, we'll not go into this condition because start is not equals to I. Now for the node 1, start value is 1 and the current node value is also 1. So we'll mark this node as AI, and while the will traverse like this, we'll mark a node as 2, and until this 2 becomes 1, we'll mark dp of node as dp of 1. So mark all the node values that are connected to this node as a cycle. Mark all the nodes dp value to 4. Okay, and otherwise the cases of 5, 6 and 7, 5, 6 and 7, the node is not visited in the current run, but the node is visited. Okay, the node is not visited in the current run, but the node is visited. So we'll mark that in that case dp of I as dp of AI plus 1. Okay, and at the end we'll mark traverse of I as 0, and we'll return the start node. Okay, and the rest of the part is quite simple. After we'll try, if the current node is not visited, we'll do dfs of I, and at the end we add dp of I value to answer every dp of I value. Dp of I means that the number of nodes we can go to from the current node I comma j. Okay, so at the end we'll mark all those nodes I comma j pairs, and we'll return the answer. Okay, I hope you get the explanation. If you still have any doubt in any part of the explanation or code, you can always ask in the comment section. I will try to reply each and every comment. If you find this video helpful, please like the video and subscribe to my channel, and also share among your peers. Thank you.